Welcome to the deep dive. Today we're taking a really close look at a fruit you probably just grab, in the summer, the peach.
hmm
It's fuzzy, juicy, definitely messy sometimes, but underneath that simple skin, there's this incredible history. It goes back millions of years.
Yeah, and some surprising sort of geopolitical stuff, too, and genetics that most people get wrong.
Exactly. Our sources today, they're just packed with insights into Prunus persica. We're talking its journey from like a Neolithic food in China.
Right, all the way through being used in scorched earth campaigns in North America, which is quite a story.
Yeah, and right up to modern gene sequencing. So our mission today is to kind of synthesize all that. You should leave this deep dive feeling, pretty fluent in peach.
Absolutely. Fluent in peach, I like that.
And just before we really dive in, let's get a sense of the scale here. I mean, you think apples are big in temperate fruit.
They are, number one,
Yeah.
and pears are number two.
But peaches, and importantly, nectarines too, they're right there at number 3 globally.
It's a huge industry. We're talking 27.1 million tons produced globally just last year in 2023. But here's the big shocker from the sources, geopolitically speaking.
Yeah.
One single country dominates production so completely, it almost skews the whole picture.
And that country is China. It produces, something like 65% of the world's entire peach and nectarine supply?
65%.
Yes.
So massive, an unprecedented concentration.
Wow. And to put that in perspective,
Well, the next biggest producer is Spain, and they only manage about 5% of the global total. So 65 versus 5.
that's not just market dominance, that's something else entirely. It really sets the stage, doesn't it?
It really does. It underpins so much of the story.
Okay, let's unpack this then, and maybe start with what you mentioned earlier, the biggest misconception. The thing that surprises even, people who know their fruit.
Ah, yes.
Yeah.
That peaches and nectarines, commercially, we see them as distinct, right?
Totally different things in the supermarket aisle.
But botanically,
Yeah.
they're exactly the same species. No hybrid, no crossing with plums, none of that.
Mind blown already. Okay, so how do we understand that? We need the botanical basics first, I guess.
Right. And the confusion starts right with the scientific name. Prunus persica.
Persica, meaning of Persia, so modern-day Iran, which you're telling me is completely wrong. Why stick with that?
Well, it's one of those classic botanical misnomers, really. Frozen in time. When Europeans first classified it formally, they traced its cultivation back through Roman times to Persia, where it was, widely grown.
Okay.
They just didn't have the tools back then, genetics or archaeology, to see the deeper origins in China. So persica became, and persica it stayed. Misleading, but there you have it.
But taxonomically, it's definitely in the right place in the Prunus genus.
Oh, absolutely. Prunus is this huge, really important group. Includes cherries, apricots, almonds, plums, all those stone fruits.
And Prunus itself is part of the Rosaceae family, the rose family.
That's it. So yeah, when you bite into a peach, you're eating a distant cousin of a rose.
And we call them drupes, or stone fruits. That's because of the hard pit inside, protecting the seed.
Exactly.
Yeah.
That's stony endocarp. Now, the tree itself, it's actually considered quite a handsome tree, often planted just for the blossoms in spring.
Right.
But, and this is key, it's relatively short-lived. Compared to an oak or even an apple tree, commercially you're looking at under 20 years of good production usually, though they can get tall, maybe 10 meters, if you just let them go.
That short lifespan is interesting. Does that mean it puts all its energy into fruiting fast?
Pretty much, yeah. It's a high-yield, short-cycle strategy for the plant. And another thing, they're quite neat growers. The sources point out they don't typically produce suckers, those shoots from the base.
Oh, those are annoying on other trees.
Exactly. And no thorns. But underground, they're surprisingly tough. The root system is deep, and it keeps growing through the winter, even when the top looks dormant, getting ready for that spring burst.
Okay, so above ground, what are the key features? Bark, leaves.
Bark is dark gray, usually has these horizontal lenticels, little pores for gas exchange.
Yeah.
Gets rougher with age. The leaves are pretty distinctive. Oblong to lanceolate, quite big, 7 to 15 centimeters.
Right.
And often, they have this fold along the middle rib. Serrated edges and little glands sometimes on the edges can be reddish.
And then the flowers, which are beautiful and self-fertile, you said. That's handy for gardeners.
Very handy.
Yeah.
It means you usually only need one tree to get fruit. And they bloom early.
Cool.
That's crucial. Northern Hemisphere could be February, March, definitely before the leaves come out.
Which makes them vulnerable, I guess.
Hugely vulnerable to frost. We'll get into that. But yeah, the flowers themselves, white to pink to red, Pink or red is typical for the fruit varieties we eat.
Okay, so it takes, what, 2 or 3 years to start bearing fruit? And the growth pattern is complex, something sigmoid?
Double sigmoid curve, yeah. It sounds technical, but it's basically phase 1, rapid growth of the fruitlet. Phase 2, growth slows right down. Phase 3, another burst of rapid growth just before ripening.
Why the slowdown in the middle? What's happening then?
Ah, that's the critical part. That's when the tree focuses energy inside. The pit is hardening. The seed inside is developing. The flesh growth pauses.
I see.
Only when that protective stone is fully formed does the flesh start its final swell, that rapid maturation phase. It's all about protecting the next generation first. Affects harvest timing, too.
Which brings us back to the pit, the stone. You said it's different from its relatives, like the almond, even though they're both prunus.
Yeah, subtly different but distinct. The peach pit is usually larger, maybe less perfectly round than an almond kernel. But the dead giveaway is the texture.
Texture.
The outside of the stony pit. It's not just pitted, like an almond. It's also deeply furrowed. It has these definite grooves or wrinkles etched into it. Almonds are just pitted. That furrowing screams Prunus persica.
Got it. Deeply furrowed. Okay, so we've established the name is wrong. The structure's complex. Let's fix the history. China, not Persia.
Absolutely. The proof is in the genetics. The greatest genetic diversity, the ancestral home, is undeniably China. It was domesticated there way back in the Neolithic period.
And that date keeps getting pushed back, right? It wasn't just 2000 BCE.
No, much earlier. There was major research published in 2014, found evidence of domestication starting as early as 6000 BCE. That's 8,000 years ago.
Wow, where was this?
In the Yangtze River Valley. Specifically near Hangzhou in Zhejiang province, the Kuokia site. This puts peach cultivation right alongside some of the earliest known farming anywhere.
And even before humans got involved, peaches or their ancestors were around for ages.
Millions of years. We have fossil evidence, endocarps, those stony pits again that look just like modern peach pits, found in late Pliocene deposits in Kunming.
How old?
Dated to about 2.6 million years ago. They even named it Prunus kunmingensis. So the basic design, the stone fruit strategy, is ancient. Humans just tapped into it.
Okay, so starting in the Yangtze Valley 8,000 years ago, how did it spread everywhere? It seems incredibly successful.
It was. Hardy, tasty, easy to grow from seed. It moved east pretty quickly. Reached Japan maybe 4700, 4400 BCE. And southwest to India maybe 2500, 1700 BCE.
The journey west took longer.
Much longer. It eventually got to Greece around 300 BCE. Though the story about Alexander the Great bringing it back is probably just, a nice story.
But the Romans definitely had it.
Oh, yeah. By the 1st century CE, it was common. We see it clearly in those amazing wall paintings preserved at Herculaneum from before Vesuvius blew in 79 CE. Detailed pictures. It was well established across the Roman Empire.
But then production collapsed in northwest Europe around the 6th century. What happened?
Likely a combination of things. The fall of the Western Roman Empire meant the loss of sophisticated horticulture skills and infrastructure. Plus, climate shifts, maybe cooler periods. Fruit growing took a hit. It revived a bit later, maybe around the 9th century.
And the next big jump was, predictably, colonialism.
Right. Spanish explorers took it to the Americas in the 16th century, and it just took off there. Argentina had it by 1580, and it spread north from there.
And this is where the story in the U.S. gets complicated and quite dark. It seems indigenous communities adopted it really fast.
Incredibly fast. Faster, maybe, than some European colonists. Records show Native Americans in Virginia growing peaches by 1629. Some sources even suggest their varieties were better adapted, maybe finer tasting, than the early English imports.
It became a vital food source for them.
Absolutely. Reliable, storable when dried, which tragically made it a target, a weapon of war, essentially, used by the U.S. military.
Destroying food sources as a tactic.
Exactly. Scorched earth. The sources mention the Sullivan expedition in 1779 against the Iroquois Confederacy in New York. Destroying vast orchards, including peach plantations, was a key part of breaking their ability to sustain themselves.
And the Navajo campaign is maybe the most infamous example. Kit Carson in 1864.
Yes, in Canyon de Chelly. Soldiers wrote about destroying thousands of what they called the best peach trees. It wasn't collateral damage. It was deliberate agricultural and cultural destruction. A terrible chapter. But there's also this incredible story of resilience there.
Right. The Navajo didn't just give up on their peaches.
No. They managed to save pits. And remarkably, peach trees are quite vigorous. Many of the trees that were cut down actually resprouted from the stumps. So by the 1870s, 1880s, they had managed to restore many of their orchards. It shows how deeply rooted the peach had become. both culturally and literally.
And that resilience speaks to how successful the peach is, not just in cultivation, but just spreading on its own, as an escapee.
It's incredibly successful at that. Think
Yeah.
about it. People eat the fruit, toss the pit. If conditions are vaguely right, boom, a new tree.
So it's basically gone feral worldwide.
Pretty much. Naturalized or escaped across Central Asia, Europe, parts of Africa like South Africa, Ethiopia, Australia, New Zealand. Most of the contiguous U.S., it's a real opportunist.
Okay, let's shift gears to growing them today. Modern cultivation. Despite that history of toughness, growing peaches commercially seems really challenging, especially with climate.
Oh, it is. The number one hurdle is the chilling requirement.
Right, they need that cold period over winter.
Yeah.
How much?
Most common types need between 600 and 1,000 hours, where the temperature is between, say, 4 and 10 degrees Celsius, roughly 40 to 50 Fahrenheit.
1,000 hours below 10°C? That's a lot. What if they don't get it?
Bad news. Dormancy isn't broken properly. Blooming is erratic, delayed. Buds don't open well. You get very poor fruit set. Basically no crop.
So you need specific climates or
Oh,
specific varieties.
Exactly. Growers in warmer regions rely on low-chill cultivars. Some need less than 100 hours. Bred specifically for places like, say, high altitudes in the tropics, where winters are mild.
So it needs cold, but it's also super vulnerable to cold, especially because it blooms so early. That sounds like a nightmare for growers.
It's the biggest risk, definitely.
Yeah.
The tree itself can handle deep cold, maybe minus 26, minus 30 Celsius. But the flower buds, much more delicate.
How delicate.
They can be killed off between minus 15 and minus 25 C. And because they bloom so early, maybe February or March.
Right when you get those late spring frosts.
Precisely. A dip below about minus 1.1 Celsius, just below freezing during bloom, can wipe out the entire year's harvest. It's a constant gamble.
Wow. What else makes them tricky to grow besides temperature?
Disease is a big one. Peach leaf curl, it's a fungal disease, loves cool, wet conditions during bud break, can devastate the foliage and weaken the tree. Fungicides are pretty standard in many regions.
And they're hungry trees.
Very hungry. They need well-draining soil, sandy loam is ideal, and they need way more nitrogen fertilizer than, say, apple trees. You can see nitrogen deficiency easily, yellow leaves, poor growth.
Okay, and then there's this practice that sounds kind of wasteful. Thinning, removing fruit.
Ah, yes. Thinning. It sounds counterintuitive, but it's absolutely essential for quality.
Why?
If you let every single flower develop into a fruit, the tree just can't support them all properly. It spreads its resources too thin.
Oh.
You end up with lots of tiny, sour, flavorless peaches. So growers have to go through, usually mid-season, and physically remove a large percentage of the developing fruitlets.
To force the tree to focus on the remaining ones.
Exactly. So those ones get bigger, sweeter, develop better flavor, quality over quantity.
Makes sense. Okay, let's talk varieties and genetics. The peach genome was sequenced back in 2013. What did that tell us?
It was a huge international effort. Mapped about 227 million base pairs across its 8 chromosomes. And the big takeaway, humans have really shaped this fruit, and not always in ways that maintain diversity.
How so?
The analysis showed clear evidence of major genetic bottlenecks. Domestication and breeding have drastically reduced the overall genetic diversity compared to wild ancestors.
We picked the traits we liked and lost others along the way.
Basically, yes.
Yeah.
2 main bottlenecks. The first was that initial domestication in China, selecting for larger, sweeter fruit thousands of years ago. The second was more recent during its spread to Europe, and especially with modern breeding programs in the West.
Focusing on what? Shipping? Appearance?
Pretty much, which leads to how we categorize them today. You've got your 2 main types based on the pit.
Clingstones and freestones?
Right. Clingstones, flesh sticks tight to the pit. They're firmer, hold their shape well when heated. Perfect for canning, processing.
Freestones.
Flesh comes away easily. Much cleaner to eat fresh. That's what you usually want for slicing and eating raw.
And now modern breeding seems obsessed with making them tough, right?
Undeniably. The big push has been for firmness. So they survive being picked by machine, packed, shipped thousands of miles, also getting that really nice red blush for eye appeal in the store. And shorter fuzz.
Shorter fuzz. What?
Easier to handle, maybe looks cleaner.
Yeah.
But the big casualty in all this focus on toughness and looks.
Is flavor.
Often, yes. Those complex volatile compounds that make a peach taste amazing, they're delicate. Breeding for shelf life and appearance has frequently meant sacrificing flavor. It's a common complaint.
Okay, now for the big reveal we teased earlier, the nectarine. If the peach is Prunus persica, the nectarine is.
Prunus persica, same species, exactly the same.
So not a peach plum cross, that's what I always thought.
Nope. Common myth. It's just a natural genetic mutation of the peach. A spontaneous one.
How does the fuzz just disappear then?
It's down to one gene, a single recessive allele. Fuzziness, those little hairs called trichomes, is the dominant trait.
Okay.
But there's a gene, PPMYB25, it's a transcription factor. If a tree inherits 2 copies of the recessive version of this gene, poof, no fuzz. Smooth skin, a nectarine.
So if it gets even 1 copy of the dominant fuzzy version.
It's a peach. Simple Mendelian genetics, really.
Fascinating. And does the lack of fuzz change anything else besides the feel?
Yeah, visually the skin color looks brighter, more intense, without the fuzz kind of muting it. Nectarines are often slightly smaller, sometimes a bit sweeter. That vivid color probably fuels the plum cross myth.
And just to confuse things further, there are things like peacherines.
Yeah, that's mostly a marketing name. You see it in Australia and New Zealand sometimes. Claiming a cross, which, well, given that the same species is biologically a bit weird.
And flat peaches, donut peaches.
Right, the Pantao types. Just a different shape, still Prunus persica, genetically fascinating variety within the species.
One last science bit, ripening. You mentioned shipping demands durability. Peaches ripen after picking, right?
They do. They're climacteric fruits, like bananas or tomatoes. They continue ripening after harvest, driven by ethylene gas and auxin hormones.
Which is great for shipping. Pick them hard and green.
Exactly. Ship them, then ripen them near the market. But there's a trade-off.
Nutrition. Flavor again.
Both, potentially. Sources suggest vitamin C levels are highest when the fruit ripens fully on the tree. And commercially, they often use a chemical, 1-MCP, to block ethylene and delay ripening even further for transport.
And that affects flavor.
It does. It keeps them firm longer, but it's known to hinder the development of those complex aroma compounds. Another hit for taste in the name of logistics.
Right. Let's move from the orchard to culture. The peach carries so much symbolic weight, especially in East Asia. Longevity seems key.
It's the ultimate symbol of long life and vitality in China, and that goes way back. The ancient Chinese observed the peach tree flowering incredibly early, bursting with life when everything else was still dormant. More vitality, they thought, than any other tree.
And they believed that vitality could be harnessed.
Absolutely. Peachwood became a powerful tool against evil spirits, against spectral forces. You'd have peachwood rods used by exorcists, amulets carved from peach pits or wood for protection and health, even peachwood bows to shoot arrows and dispel evil.
Wow, so planting one near your door was literally for good luck and protection, and there's a specific deity associated with it.
Shojin, the god of longevity. You almost always see him depicted holding a giant peach or leaning on a staff topped with one. It is the symbol of long life.
And that continues today in food.
Yeah, the shotabo.
Yeah.
Longevity peach buns, served at birthdays for older people. They're not actual peaches, usually lotus-based buns, but shaped and colored to look exactly like a perfect peach, a symbolic offering.
It pops up in famous literature too, doesn't it?
Oh, definitely. The famous Oath of the Peach Garden in Romance of the Three Kingdoms, Liu Bei, Guan Yu, Yan Fei swearing brotherhood. It signifies that deep, unbreakable bond.
And utopia.
Tao Yanming's Peach Blossom Spring. This hidden valley, discovered by chance, full of blossoming peach trees, a metaphor for an earthly paradise, a utopia away from the world's troubles.
And then there's this other really intriguing term, fontao, the divided peach.
Ah, yes, fascinating bit of cultural history. Fontao became a classical literary allusion, a byword, for male homosexuality in China.
How did that happen?
It comes from a story in the Han Feizi, an ancient text, about a courtier named Missy Xia and his lover, Duke Ling of Wei. Missy Xia was eating a peach, found it delicious, and gave the rest to the Duke to share.
A gesture of affection.
Initially, the Duke praised him for it. But later, when Missy Xia fell out of favor, the Duke used that same act. He even gave me a peach he'd already bitten, as evidence of his disrespect. Shows the fickle nature of power, but the term fontao stuck, signifying that intimate sharing.
Incredible context for just sharing a piece of fruit. Does that symbolism carry over elsewhere in Asia?
It does, with variations. Peachwood wands are still used in Korean shamanism for protection. In Japan, you have the super famous folktale of Momotaro, the peach boy, born from a giant peach.
Right.
And in Vietnam, the blossoming peach flower, hoa đào, is the signal of spring, absolutely central to the Tet Lunar New Year celebrations.
Okay, shifting westward. How did the peach feature in European art? Renaissance painters loved it.
They did. Caravaggio, Renoir, Monet, Van Gogh. Lots of famous still lifes feature peaches prominently. The symbolism was a bit different, though related.
How so?
Scholars suggest that in Renaissance symbolism, the peach often represented the heart, and if it had a leaf still attached, the leaf symbolized the tongue.
Heart and tongue. So speaking truth.
Exactly, speaking truth from one's heart. Sincerity. A ripe peach could also just symbolize good health and vitality, similar to the East Asian meaning.
And Caravaggio, you mentioned, brought a certain realism to it.
Yeah, he was famous for it. While others painted perfect, almost unnaturally flawless fruit, Caravaggio would paint peaches with, say, a wormhole in a leaf, or a slight bruise or blemish.
Why?
It added this layer of realism, maybe even a moral or spiritual message. Like, even truth or health in this world are subject to decay, to imperfection. It wasn't just decoration, it was commentary.
Now let's tackle that American paradox, Georgia, the peach state, which isn't quite accurate anymore.
It's a classic case of branding success outpacing reality. Georgia absolutely earned that nickname in the late 19th century, 1870s, 80s. They were huge producers then and brilliant at marketing and shipping them north.
But today?
Today, California is number one by a huge margin. Then South Carolina. Georgia is third. And peaches are actually a tiny fraction of Georgia's total agricultural economy now, less than 1%.
So the nickname stuck, but the industry shifted, and there were political reasons for promoting the peach back then.
Definitely. It was part of that post-Civil War New South narrative. Promoting peaches, a high-value, clean crop, helped project an image of progress, moving beyond the reliance on cotton.
But that narrative had its own issues.
It did. It often glossed over the labor reality. Just like cotton, the peach harvest relied heavily on black labor, often under exploitative conditions that the progressive image tried to obscure. So the nickname itself is tied up in that complex history of race, labor, and regional identity.
Despite the production shift, the peach is still official state fruit there.
Yep, Georgia made it official in 1995, and South Carolina, the #2 producer, actually beat them to it, designating it state fruit in 1984. Delaware uses the peach blossom as its state flower, too.
Okay, wrapping up with health. What's actually in a peach, nutritionally?
Mostly water, about 88%. About 10% carbohydrates. Pretty low in calories, around 46 per 100 grams. The sweetness mainly comes from sucrose.
But the health benefits are more in the micronutrients, the phytochemicals.
That's where the power is. They're packed with polyphenols.
Oh.
Things like chlorogenic acid, catechins, epicatechins, powerful antioxidants. If you like red flesh peaches, they're rich in anthocyanins, too.
And where are these compounds concentrated?
The skin. Things like flavanols and cyanidins are highest right in the skin. So if you tolerate the fuzz, eating the skin is definitely the way to get the most benefit.
To know. And that amazing smell, we said it's complex.
Incredibly complex. Around 110 different volatile compounds have been identified contributing to that classic peach aroma. Alcohols, ketones, esters. The exact blend varies a lot between cultivars.
Which explains why some taste bland and others are amazing.
And why breeding for shipping can accidentally kill that aroma profile.
Right. Lastly, the warning, the pit. It's related to almonds, cherries. They all have this issue, right?
Cyanogenic glycosides, specifically amygdalin in peach seeds. It's a chemical defense for the seed.
And if you eat it,
your digestive system breaks down amygdalin into sugar, benzaldehyde, which gives that faint, bitter almond smell, and crucially, hydrogen cyanide, which is highly toxic.
So definitely don't crack open pits and eat the kernels.
Definitely not in any quantity. The risk is real. Although, commercially, they do use it. Because the kernel does taste like almond, processed peach kernels are used to make something called persipan. It's like marzipan, but cheaper, using peach kernels instead of almonds. Used in baking sometimes.
Huh. Okay. And allergies. Are peach allergies common?
Relatively common, yes. Linked to proteins in the fruit, especially the skin. Reactions can range from mild, like itchy mouth oral allergy syndrome, all the way to severe anaphylaxis.
But peeling helps sometimes.
Often, yes. Since some key allergens are in the skin, peeling can make a difference. Also, cooking or canning denatures the proteins, so canned peaches are often safe for people allergic to fresh ones.
Okay, what a journey. We started with this massive global production dominated by China.
All right, 65%. Then dove back 8,000 years to its origins in the Yangtze Valley. Traced its tough journey west, and its, frankly, dark role as a tool of war in North America.
We unraveled the Botany nectarines just being fuzzless peaches due to one gene, saw how growers fight climate, needing chill but fearing frost.
and how that relentless drive for shippable, good-looking fruit has often pushed flavor down the priority list.
So yeah, what this all means is that simple piece of fruit you hold, it's loaded. Millennia of history, deep cultural roots from China to Europe, complex genetics.
It really is. Which leads to a pretty provocative thought for the future, doesn't it?
Go on.
We know modern breeding has sacrificed flavor for firmness and looks. We know the genome is sequenced. We know roughly which of those 110 volatile chemicals create that perfect peach aroma. So what's the responsibility now? Do breeders have an ethical or even commercial duty to use that knowledge not just for logistics, but to actively restore the amazing flavors of tree-ripened peaches? Think about it. There are nearly 500 recognized cultivars in China alone. What incredible lost taste might be hiding in that vast genetic library, waiting for us to find them again and bring back real flavor?
Something fascinating to think about next time you bite into a peach. Thank you for joining us on this deep dive.